So now we get to the part where we're ready to actually apply these hypothesis tests and solve problems. And so to try to put this in a kind of concrete setting so that you can kind of get a real life feel for what we're actually doing with a hypothesis test, I'm going to present two general case studies, and I'd like you to stop the video and I'd like you to read each of the case studies here. I'd like you to think about what the population is here. So for each of these, I want you to think about what is the parameter that we're interested in each of these scenarios, what is the variable, and what is the population. So this is going back to chapter 2 and building on our skills to be able to form statistical questions. Since the hypothesis test is a statistical question, we have to go through this process. So go ahead, stop the video and do that. Okay, I'm going to assume that you now restarted the video. So in Bardo's case, you should have realized that we're talking about a quantitative variable, and we're going to be talking about the average here, the average weight of the loaves of bread. So our parameter is going to be mu, a population average. The way we know that is the only thing we're talking about here is a quantitative variable, which is the weight of a loaf of bread. And the population is going to be all the loaves of bread he makes with his new machine. So this will be the population. In Mr. Burns' case, we see percentages. We see that he's making loans. He wants to know what percentage of customers are taking out loans. So hopefully when you puzzle through all this, you realize that you're looking at a population proportion. And the variable is whether a customer in his bank has a loan or not. Has a loan with the bank. And of course, the population is all the bank customers. So putting this all together, what is Bardo going to be interested in? Well, he's going to be interested in the average weight of all the loaves made with his new machine. Okay, notice how we put this all together. This is average, this is the variable, this is the population, the average weight of all the loaves of bread made with his new machine. Right? That's going to be Bardo's parameter. Mr. Burns, he's going to be interested in the percentage of all the bank customers that have loans. So let's just write this out. Okay. So this will be the average weight of all the loaves made with the new machine. Made with the new machine. Okay. Average weight of all loaves made with new machine. And the population percentage is going to be the percentage of everyone in the population, all bank customers, that fall into a certain category, that have loans. Okay. So, percentage of all bank customers that have loans. Okay, good. So now we're ready to start to do some hypothesis tests. So I want to look at 6 different case studies, and we're going to do hypothesis tests for each of them. And these are real life case studies that people do a common basis in business. I want you to read the problem statement and try to at least answer the first two questions. So go ahead and stop the video. Okay, so you started the video back up again. So we know that we're doing a hypothesis test on pi. Okay, and when we read it, we say he knows last month the percentage of customers holding loans was 15%. So this is the prior value for pi. So the null is that pi is equal to 15%. If he had no new information, he would assume the percentages are the same as last month's. A new tax incentive to encourage families to purchase homes was passed this month, and it seems the percentage of loans has increased. So a change has occurred, right? And what we want to test to see if it's increased. It seems this way. This is what we want to test. Mr. Burns takes a random sample of 500 customers and finds that 18% of them currently have loans with the bank. Run a hypothesis test at significance level of 1% to decide if more than. So we have three pieces of information that tell us what the alternative is. First, this is kind of our hypothesis here, right? It seems the percentage of loans has increased. Notice that our sample percentage is greater than the old value. Again, the sample percentage has to be in favor of the alternative. And here it actually says in the hypothesis test what we're testing. So we have three different ways to verify that our alternative is that the population of percentage of the bank customers that have loans is greater than 15%. Our sample size and our estimate. Well, we took 500 customers, right? Our sample percentage was 18%. Okay. And now we're ready to start to get into some calculations. So we want to know what is the null distribution. So it's important to understand that the null distribution, what it is it's the distribution of sample estimates if the null hypothesis was true. Okay? So if the null was true, then the central limit theorem tells us. And by the way, we have to make sure we can use the central limit theorem, right? Can we use it? Well, let's check. We need a random sample. Do we have that? Check. Is it big enough? Well, we have to find out if this product is greater than 10, and if n times pi, 500 times 15 is greater than 10, and it is, and the sample size times 1 minus pi, 85 is greater than 10, and it is. So that part's okay. Is it too large? This is a kind of subtle question. We have a sample size of 500. Does the bank have at least 5,000 customers? Well, we're going to assume that they do. Okay, banks are relatively large. Usually they have more than 5,000 customers. So we're going to go ahead and assume we can use the central limit theorem. But we had to check the conditions first, right? So the central limit theorem tells us that the sample percentages have a normal distribution. The mean is the value under the null hypothesis, and the standard deviation is, and the mean under the null hypothesis is pi naught, okay? And the standard deviation for the sample estimates is going to be pi naught times 1 minus pi naught divided by n square root. And we're going to do this calculation in Excel. So let's go ahead and see how this works in Excel. Okay, so let's go ahead and open up Excel. And just like we've done before, it's going to be a good idea to set up an Excel sheet where you have quantitative and categorical variables separately. I'm not going to post this Excel sheet. I want you to learn how to create these Excel sheets, and I want you to think about what's in them. So you can go ahead and follow this video, but I want you to actually type it in. I think if too much of the work is done for you, you don't really, it doesn't really click and sink in as to how you got uh, those values. Okay, so I'm going to make this tab here hypothesis test. Okay. And I'm going to think about what I need, okay? So let's think about the input. What do we need to input here? Well, I need a couple of things, right? I need the sample size. If I'm given the raw data, okay, I might need to compute the number of successes. That is the number of number that's in the category of interest. And then I'm going to need pi hat, right? I need my sample estimate. And I'm going to need pi. And I'm going to say pi sub 0. Okay, this is the value of pi under the null hypothesis. And what I'm going to do is I'm going to kind of look ahead a little bit, and I'm going to think about the types of hypothesis tests I might want to run. Because I have different types of hypothesis tests, right? I might want to run a lower test. I might want to run a two-tailed test. And I might want to run an upper-tailed test. Okay? And I'll put the word tails. And nothing will change with the input, but when I compute the p-values, things are going to change a little bit, okay? So what sort of test am I doing here? Well, I'm testing to see if the percentage is greater than 15%. So I'm doing an upper tail test, okay? So let's go ahead, we'll make this a little bit bigger. And here my sample size is 500, okay? Number of successes I don't need because I'm given pi hat. So I know that pi hat's 0.18 and the value under the null hypothesis is 15%. Okay. So what do I need? Well, I need the standard deviation of pi hat. And this is what we get from the central limit theorem. It's equal to the square root of pi naught times 1 minus pi naught divided by the sample size. That's what I'm going to type in. There we go. Okay, so let's go ahead and compute this. Okay, so this is going to be equal to the square root. And you have to be a little careful here, okay, because you're going to say 1 minus pi naught, but you have to make sure that it's in parentheses, okay? Divided by the sample size, and I'm taking the square root of that whole thing. And now I want the p-value. So if we think about this, these are the two parameters for the normal distribution, and this is my data value. So I want to know the upper percentile for this data value in this normal distribution, right? And I'm going to go ahead and round these off a little bit. We don't need quite as many decimal points. We'll keep 4 because sometimes these numbers get a little small. And there we go. Okay. Good. So our p-value is going to be the area in the upper tail. So I'm going to say 100 times 1 minus, and now I'm going to use norm.dist. This is my data value. This is the mean of the normal distribution, and this is the standard deviation. And that's my p-value. Okay? So it says that if the null hypothesis is true, if the percentage of people in the whole bank that hold loans is 15%, then the likelihood that I could get a sample percentage of 18% or higher is only 3%. That's what we're saying here. And so our statistical decision, well, let's think about it, right? So our p-value here, which is roughly 3%, is greater than 1%, which is alpha. So when the p-value is less than alpha, we fail to reject the null hypothesis. Okay? In other words, there's some evidence but not enough. So what would our conclusion be? Well, we would say at a significance level of 1%, we find there is not sufficient evidence to conclude that percentage of customers, say percentage of bank customers, having loans is greater than 15%. Okay? That would be our final conclusion. Again, notice that the conclusion and the statistical decision are two different things. They're not the same thing. It's important to understand that. Notice something else interesting. If I had chosen an alpha of 5%, I would have rejected. So sometimes people don't like to choose alpha. They just like to report the p-value, and they let the individual make up their mind. Okay. All right. Good. I think I'm going to break up these problems into separate videos, and that way it should help, I think.